All right, example 4, we're going to graph the reciprocal function. How do you graph the reciprocal function y equals 1 divided by x, 1 over x? So let's define what a reciprocal function is. It maps every non-zero real number to its reciprocal. All right, first we want to consider the domain and range. So domain is going to be your input. We know that that is the x values. We haven't used this notation in a while. Your domain is all of your x's such that. Now let's look at our function over here. 1 divided by x. Can x be all real numbers? Or is there anything that x cannot be? What is starting to change in this chapter is we have a fraction and x is now in the denominator of your fraction. Are there any numbers in math that you cannot divide by? Is there anything we shouldn't let x equal? And maybe you're starting to think, oh yeah, well, you can't divide by 0 in math. We get that error message on our calculator when we try to. So that is when this function would be undefined if we let x equal a 0. So we're just going to not let x be that 0. We're going to say x can't equal a 0. Because if we put in a 0 for x, 1 divided by 0 would make this whole thing undefined. All the other numbers are okay for x. You can divide by positive numbers, you can divide by negative numbers, you can divide by decimals, all of that works out. All right, let's think about the range. So the range is your input values, it's all your y's, such that, so let's think, if we input all these numbers in for x, all your negatives, all your positives, we do 1 divided by those values, you're going to get positive numbers, negative numbers. But will we ever get a 0 in our range? Can we take 1 divided by anything and get back 0 as the answer? And you never will get an output of 0 if x is your denominator right there. So your y values will not equal 0 as well. So that's our domain and range. Basically, your x's and y's will be and can be anything, just not 0. All right, let's graph the function. We have a pretty big table of values here. That's okay, we'll be thorough. If x is a negative 3, y is the reciprocal of that, 1 over our negative 3. So the reciprocal of negative 3 is just a negative 1 over 3. If x is a negative 2, our function is a negative 1 over 2. If x is a negative 1, our function is a negative 1 over 1, which is just a negative 1. Now, if x is a negative 1/2, here's what this would look like. Negative, or 1 divided by a negative 1/2. Mathematically, you would actually flip by the reciprocal by a negative 2 over 1, and we get a negative 2. So if x is a negative 1/2, your y is a negative 2. If x is a negative 1/3, your y is a negative 3. If x is a 0, you are undefined. We cannot graph or have an ordered pair where x is a 0. All right, let's plug in a 1/3. 1 divided by a third is 3. 1 divided by a half is 2. Another way to think about these is if you have 1 divided by a third, how many thirds fit into 1? 3 of them. How many halves fit into 1? 2. All right, 1 divided by 1 is 1, 1 divided by 2 is 1/2, and 1 divided by 3 is 1/3. So all we just did is we took these x values and we plugged them in for that x right there. Now let's go ahead and plot those points. We'll have to do some estimating because I see some fractions on here, but that's okay. We have, let's see, negative 3, negative a third, it's about there. Negative 2, negative 1/2, negative 1, negative 1. Oh, negative 1/2, negative 2, and negative a third, negative 3. It's a little bit closer right there. So we can see that we are getting kind of this curve shape right here. That's a new shape for us. We haven't graphed anything quite like this before, so that's exciting. All right, if x is a third, the y is a 3, so we're just up here. When x is a half, y is 2, just over a little bit more. We've got the ordered pair 1, 1, and then we have 2 when your y is a half, and then 3 and a third. So what you notice is we have two kind of separate curves right here. Let's go ahead and draw in those curves. What we will begin to learn in the next couple steps is that when we draw these in, these curves are never going to touch the x-axis where y equals 0, and they're never going to touch the y-axis where x equals 0. So remember, in our domain and range, we said the x will not be 0 up here and the y will not be 0. So here's what it looks like graphically. We won't have any points on those values. So let's draw in the curves. What we do is we kind of get super close to that 0, but we just don't cross it. There's one curve. And here's our second curve. So that's the general shape of these graphs we're going to be looking at this chapter, so that's fun. All right, step 3, observe the graph as the graph of 1 over x as it approaches positive infinity and negative infinity. All right, so here's our table of values. We can see that x is getting bigger. 1, 10, 100, 1,000, 10,000. It's approaching positive infinity. We could continue this forever. What would our function, the value of our function be as we do this? So remember, our function is 1 over x, so 1 over 1 is just 1. Then we would have 1 over 10, so we got smaller. 1 over 100, well, if you divide by 100, you're getting even smaller. 1 over 1,000 is even smaller. 1 over 10,000 is so small. But if you notice the pattern, as our x's get bigger, the y's are going to get smaller, 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 smaller. The thing, though, is that they will never equal 0. It's always going to get tiny, 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 but it never actually can equal 0. So that brings us to the idea of an asymptote. An asymptote is a line that the graph approaches. Asymptotes will guide the end behavior of a function. So what we just discovered was that as our x's approach infinity, f of x, our function, is approaching 0. It's going to get closer and closer and closer to 0. Now the same thing would be true on the left side of your graph. As x approaches negative infinity, you're going to get your y values, the function is going to get smaller, 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 just with negatives. So our function will also approach a 0, which means the line y equals 0 is an asymptote for the 1 over x function. So what we saw there, just to give you the visual in our graph, is that curve. As the curve was heading out toward positive infinity, it's just going to get closer and closer and closer to this y equals 0 line. It will never touch it and never cross it. We also had a curve here as we were approaching negative infinity. So as our x's head out to the left, you can see that it is going to get closer and closer and closer to this horizontal line y equals 0, but never cross it.